Good afternoon, everyone. You're welcome to this platform today. This is our first session, and hello, everyone. This is Niger Data Platform. This afternoon, we'll be talking about Excel data, functions, and formulas. Would like to say hello to our partners, which are Microsoft, Gyre Computer Solutions, Enterprise NDA. If you require further training, either self-paced or paid for, kindly check one of our partners out. They are more than sufficient for all these training. I'll be introducing our speaker for today, and that is the wonderful Eno. She will be the one to take us about Excel data, the formulas, and the function. She has an engineering background. She has worked in the IT industry for more than 10 years and delivering quality engineering services in the banking and payment industry. She's also a Microsoft certified trainer and she's data driven. So she will be the one to take us for this section. We are going to wait for another 3 minutes for other people to join us before we start properly. Welcome on board. Sorry, everyone. Welcome on board. We are waiting for other people to join us. 2 more minutes and we will start the class fully. Thank you. Sorry, everyone. Welcome on board. We are waiting for other people to join us. 2 more minutes and we will start the class fully. Thank you. All right, this is 5 minutes after 3. I'm going to bring our speaker on board. Eno, please take the floor, please. Thank you.
Hello, everybody. Can you hear me? Good afternoon, everybody. My name is Eno, as well introduced before. Today, we're going to be talking about Excel data, functions, and formulas, the basics of the Excel data for beginners for Excel. But before we get started, I would like to ask, how was your Saturday and how have you been? How's the weather been? For my own area, the weather has been good, it's been fine. And I would like, in a scale of 1 to 10, being 10 as the highest, kindly rate your Excel usage so I will actually know my own audience. Can I see your response? Okay. I have Ogechi here. He said 6. Do I have any other person? Hello, do I have any other person?
I think it's only Ogechi we have.
Oh, okay. All right, so Ogechi, so a 6 means you're an intermediary in the uses of Excel and you're actually conversant with most of the things we're going to discuss for the beginners and maybe just like a refresher to you on this journey. Okay, so let's get started. So Excel on its own is actually a very productive tool and it's actually used to organize data and analyze data, used for calculation and visualization. For Excel, it's actually an important tool used in different companies and organizations. And Excel as a tool is used for record keeping and also for data tracking. Each data in Excel is actually stored in Excel objects, and these objects are called what? As the data are stored in what? Cells, columns, sheets, rows, and also in tables. So as we go on with the presentation, we would be having a practical session on and we actually explain what a cell, a column, or a sheet is all about. There are essentially 4 Excel data, namely the text data, the number data, the logic, and the error data. So I would like to go to my worksheet and would explain further what a text is and what a cell is. Okay, so I'm going to bring my grid lines back for us to have it. So my cursor is on M5. So I will represent this as a cell. This is a cell in Excel. This is called a cell. And M, it's a column. So M is a column. We said Excel data is represented in either a cell, a column, or a row. So this number 1, it's actually a row or a row. Then the whole of this Excel that we are seeing now is called a sheet. So if I do a new sheet, I open a new sheet, I'll be having this whole Excel function is what? A sheet. So we are going to be going to our number 1 data type, which is the number data type. So I would like to go back to our presentation. So number data type, as it's actually being called, it's categorized, it includes any kind of numbers. So for example, you would have a monetary total, you have a whole number, you have percentages, you have decimal, full number. I would like to iterate that date and time are actually number data. So sometimes that is being confused whether it's a text data, but date and time is actually a number data. And also in Excel, Excel is justified from left to the right. So I'll be going to my worksheet to actually show an example on what the examples of the monetary data is. So this is our Excel sheet. And we have different columns and we have different rows. So this is a data. We're having items, bags, shoes, different types of items, and we have the cost price of it. So we said that number data at what whole numbers. So this is actually a whole number or a decimal. This is also a decimal. And a moment, please. So I've made all this, my cost price, actually whole numbers, as well as I can actually make my cost price decimal based on our monetary value. We know that when we're having a monetary value, we always have a decimal, depending on the money. Either if you're talking about Naira, you always have a kobo representing in every money. So for this total, so I want a monetary value for all the cost price of what these items that were bought. So for example, I would do this. I'm going to sum this just to get a monetary total, just to illustrate how monetary totals are actually done in Excel. So the monetary total I had here is in pounds, so that can also be changed. If I don't want my monetary total to be in pounds, I could do that in dollars, and so we have different monetary totals that we may do, and we found out that each of these is presented in Excel and is not actually giving us an error. So we're also told that number data is also presented in percentages. So on this my cell, I would have different numbers. Let me make it cell general. A moment, please. So I'll have different numbers in a row, and I'll also fill it. A moment, please. So let's assume I want to find the percentages of this number. Okay, let me make this a decimal. I said that Excel is actually left justified. So if I'm typing in Excel, you notice that 0.03. Let's assume that's what we have there. 0.5. So I'm also represent this row as percentage. So it shows us the different percentages so Excel actually accepts a data as percentage, and it will not actually give us an error. So I would like to go back to our slide to speak on another data type. Oh, sorry. I didn't speak on the date and time. Please, can we go back, please? Sorry, please. Can we go back to the worksheet? Okay, thank you. All right, so we have a date data type. So Excel would actually portray our data type. So let's assume today is the 25th of June 2022. Yes. So if I also feel that, I notice that Excel actually changes the year for me on the same date. However, it can actually also have the data different dates as in concurrently. And for the time, Excel actually recognizes time. So for example, if I have 10 a.m. and I put 10 a.m., Excel recognizes it. It's showing me a moment. Okay, so if I have 10 a.m. here and I have 1300, I have 9 a.m. If you click on this cell, Excel recognizes this 10 because it's time as 10 a.m. and recognizes this as 1 p.m. recognizes this as 9 a.m. If I say 22, because I'm reflecting time, 22:30, so it actually reflects Excel understands that as time data, that 22:30 is what 10:30 p.m. and that is recognized. So that's what we call number data. So Excel represents accepts time as a number data as well as what date. So can we go back to our slide, please? So another type of data that we have is what we call the text data. Text data actually takes all kinds of alphabetical data and also takes sentences and addresses. So we're going to illustrate on our worksheet how we can actually do have sentences on Excel and address, and Excel doesn't actually prompt it as an error. So for a text data, we have a scenario here, a data already here, having the addresses, and we have it here filled up. I would re-represent that again. Okay, I have this information. I decide to replicate this too. So I want to create a border on it in a moment. So we can actually have a good view of it. A moment, please. Okay, so we can see that for addresses, Excel is able to accommodate these addresses, and is not actually giving us an error. So for example, what if we have a particular person? So let's assume here we have name of a person, and we have a particular address, three addresses that is actually for one person. So let's assume somebody gives three addresses and another person bears the other address, for example. So I have Eno. I have three addresses that belongs to Eno, and Rita has one address, and Ham has one, and we have Dan in one. So instead of us replicating Eno on all the addresses that belongs to Eno, so there's a function called merge on Excel. So I can actually merge these cells, and it just represents Eno, showing that in your data that all these addresses belongs towards one person. So when that is done, so that's I met that cell. So it shows that Eno as a person actually produced these three addresses depending on what the information was for. Instead of having to write the same name multiple times. So we also have the fact that you can actually write sentences on Excel. So for example, this sentence, the country is moving very fast in a radical manner. It's actually a sentence on a particular cell on Excel. You can actually see the sentence, but you notice that the sentence is actually cutting across other cells, though it's only on one cell, because we say that Excel data is occupied in what an Excel object, which is either a cell, a row, or a column, and vice versa. So what would I do for me to be able to know that this particular sentence that I wrote on this Excel is actually on only this cell. So there's a function called what wrap text. So with that function wrap text, I click on that cell and I click on wrap text. It now shows that my long sentence in Excel, instead of it wraps it together and enables the person that is actually viewing the data to have a nice view of how that data, the sentence data, the text data is actually represented in Excel. So we have to go back to our slide. So we have logical data. That's one of the data that we have in Excel. So logical data is either a true or false, and usually used for comparison on a product or any of information that you want to compare with. So some of the examples are the and, the or, and the not. There are other examples of logical data that you can actually browse on. So we want to represent this logical data on our Excel platform and Excel sheet. Please. So for logical data, we have an example here. So take an example, we have a discount value of 10% dependent upon the amount a customer actually spends. So for example, we're looking at what 3,000 and how many years that particular customer has been with that particular store. So we want to use that logical function, the and or function. It actually returns either a true or false depending on the data that is being given. So the and function returns true only if every condition is met. Otherwise, it returns false. So the or function returns true if we have one function met or all the conditions actually met. So for this data, I have a name, I have the amount that was spent, I have the year that how many years each customer had spent on that particular store. So that will determine the discount that will be given. So for the an example, for every function in Excel, so you have to have an equal to sign and an and. So I'm comparing if this customer spends, this amount is what greater than or equal to what the amount that we're comparing, which is 3,000, comma. We're also comparing if the customer has been with us for more than 3 years. So it should do what return true or false. So if this customer is equals to what? 3 years. So the answer here is false. So I would also fill this. So now let's assume I actually change this to 6 years. We notice that Excel will automatically change it. I don't have to go back and rewrite the formula. Excel will actually change it to the positive answer or the negative answer. So let's assume I reduce this to actually 1 year. You say Excel changes it automatically to false on this particular cell, on this particular data that we're actually comparing with. So for the OR function, it actually goes the same way, but in this function, one of the data is either correct or all the data for comparison is what's correct. This cell, which is the amount spent by the customer, should be greater than or equals to 3,000. Then this cell, which is the number of year, we're comparing with the year of how the customer spent with us, should be greater than or equals to what? 3. So with that, for the OR function, we notice that for this year, the customer didn't spend up to 3,000, as well as the customer didn't stay with the company for what? 3 years. So dragging this, we notice that this customer actually spent 3 years, and actually spent a larger year, more than 6,000. So you can see the difference between the and the all logical data sets for comparison of products, depending on the data sets that is being presented to you for you to analyze or organize that data on Excel. I would like to go back to the slide. So another Excel data that we have is the error data. So what does error mean? All of us know the meaning of error. So once you make a mistake, an error will pop up. So in Excel, we have several errors. But for this training, we're looking into the name error. So on a name error, so for example, if we have a typo in our formula in your Excel, we would notice that the name error data would actually display on that particular cell, as well as the division error. So you know that dividing a number by 0 is actually infinite. So we divide any number by 0 on Excel, the div error data type would actually be displayed on that cell, as well as the number error. So for the number error, if you have an invalid formula or a function you are using on your Excel data, when you're trying to analyze or calculate data in Excel, you notice that the num error would actually be displayed on that particular cell, as well as the null function. So if you miss a delimiter, or for example, in a range, there's no intersection that Excel will be able to understand. It will actually bring the null function because it doesn't understand the range because there's no intersection. So we'll be going to our document to be able to analyze all these functions. Okay, so I have this little data here. I have the score, the particular score, and I have the numbering. So for this course, we're going to be looking at the different functions that we spoke about. So we talked about the name function. So for the name function, we agree that whenever we have an incorrect function, we are going to have a name function. So when we are going to be calculated in a particular formula. So for example, I want to calculate the sum of these scores that I have here. So I'll come here on the particular cell I want to do the calculation. So I'll say total is equals to. So I want to do the sum. However, I missed the particular, I didn't record it well. I missed the function, maybe by mistake. So it will give me the name error. So when I have the name error, I should go back and look at my Excel. Why is my formula wrong? Is my function wrong? Based on the data I'm analyzing. So that would enable me to be able to retract and solve that error. So that's when you have the name error. So also we discussed that the division error is whenever you're dividing a particular number by 0. So if I'm dividing this cell by 0, the div error would be displayed. So as well as the num error. The num error is when Excel cannot actually find the what you are trying to do. It doesn't understand what you are trying to do. So, for example, in this set of data, what I'm trying to do, I'm having a wrong function. I will do 2, for example. I have that function, and I just have a random number, which is not part of all the scores that I have. The non-function error. So sometimes we make a mistake. So when you have a large data, for example, you may be trying to do a calculation, and you actually miss that inside your data set, you don't have maybe that particular entity data on it, either the text data, and you use it in your calculation, or you have a wrong function, you will notice that the num error would actually be displayed in the cell that you're trying to evaluate. So for the null error, like I explained earlier, so normally in Excel, if we want to do a sum function, it goes in a range. So what are we summing? We're summing from E4 towards E9. However, if you remove this delimiter, this column sign, Excel doesn't understand what it means because there's no intersection within the data set. So you see, Excel is going to report that as what a null because he doesn't understand. There's no intersection and he doesn't understand how that can be done. So you see, so these are the little errors. There are other errors also in Excel that we can actually browse through and get accustomed with. So could you please go back to our slide, please? So those are the 4 data types that we actually have in an Excel data. And but as we said earlier, the data itself are just our informations, and these informations are categorized in these 4 types of data types. So we're going to be looking at functions and formulas in Excel. So we have different formulas ranging from the simple arithmetic mathematics to the complex engineering math statistics. There's a lot of, Excel is actually a very robust tool for calculation for different parts of life. We are laying emphasis on the basics and how this data can be used. Okay, so for these functions, we have what we call the sequence function. We have the sum. Most of us know I've been using the sum in my earlier presentation. We have average, we have count, we have a lot, we have sort, we have so many functions. However, I'm going to limit my presentation to these functions. And on this function, there are standard functions. So for example, the way you do your calculation on your sum as normal Excel standard calculation, like I was doing earlier, I drag the range and I sum it. I could actually do the same thing for average. Then I could have a set of data and I also use that function count to actually count it. The sequence is another function that enables you to do all these set of data, all these set of other formulas in sequence formula. So can we go to our worksheet so that we'll be able to. Okay, so this is my worksheet. So we'll do a little thing on this worksheet. I have the standard formula. What do I mean by standard? I'm going to do a different data set. So I'm going to copy this, but I'm going to use a different, just copy the name, but I'm going to use different data set to illustrate what I mean by standard and sequence. This is score. Now, normally in Excel, let's assume we are trying to record scores of different subjects that all these people had in class. So the person that's in the organization that is actually keeping that data would come in, either type each score one by one, you understand? One by one, it depends on how the score is, one by one, or so these scores will be typed one by one depending on what the the people actually scored in class. Sometimes this is how the score would go. Or if there's a pattern on the score, so for example, it was in the step of let's say in the step of fives or step of tens, what I would do as a person entering on Excel, I will come and do 10. The first one I will do 20. I would come and I would do what? Drag. So that enables me to do what? Instead of spending time to type it one after the other, I'm able to fill in that score in the step of what 10. So that's what I call the standard form. But when I talk about sequence, what do I mean by that? So for sequence is a formula, it's also a function. Now, I have this score. And I have the score. So I'm going to use my sequence to actually fill in my score. I don't have to type or actually have to drag or actually have to drop. So I'll do is equals to sequence as a function. Now, how many rows do I want in this in my score? What I have here is 10 rows. I take 10 rows. How many columns am I looking at? For now, I want to replicate what I did on the standard form. So I have just one column. What do I want to start with? So I'm starting with 10, which is what it is step of 10. So what step do I want? The step of 10 also. I'm starting with 10 and also the step of 10. And I close the bracket. Excel actually populates that for me. I don't have to go back and do it one after the other. Also, I can say I need a data. So that same sequence, for example, I'll use the sequence form and I said, okay, I want 5 rows. I want data in 5 rows, 3 columns. I'm starting with 2 and in what? In the step of what? And in the step of what? 3, let's assume. So it populates that data for me. Instead of me having to type it one after the other or trying to drag and that. So this is what the SQL function can do that for me. I can actually do it in a horizontal way, also in a row. So depending on using that formula. So now let's go into our calculation of a simple calculation using the standard form and also the what? The sequence form. Now I'm going to have a count for me. For me to use my sequence form, I need a count of 10. That's my count. And this is what we had before on our standard form. So for our standard form, if I need to do a sum, I will come to my cell, it's equals to sum. This is what I'm summing. And that's the answer. So I come here, I said, okay, I want to do the what average of this my particular data set. So the same thing, I get my formula, my average formula, the same range. That average is calculated. You want to do a count of what these scores are. How many was the count there? For example, outcome is equals to, and also the function count. And this value range also. So it shows me the different function. I can do sum. That's the standard way of how to do calculation in Excel, the simple calculations you want to do in Excel. However, I want to do the same thing, but I want to use the sequence formula. I want to use the sequence formula. What do I do? It's equals to sum in bracket. This is what I want to do. R it gives me the same answer. As well as if I want to do the average of that, sorry please. Instead of me going back to go and do range the way I did for the standard formula, I will just get that and then I do hash. It recognizes that and the answer is given. So my count already, I would do is equals to sequence. This is my count. Oh, sorry. So that's seconds, not sequence. The number of rows I have here is 10. And my column is what? 1. Sorry. I'm doing that in row. The column is 0. Sorry. Equals to sequence. The row is 0. Just have that. Then my column. Oh, hold on. Wait. So what I wanted to illustrate, so for the count function, I wanted to actually also calculate this sum, hold on, with this count function. Instead of doing this sum the way I did it. So I'm going to count it with this count function. So that will enable me to, in case I change this count, it will show that this column too will change. A moment, please. One, and step of 10. It's going to give me a column actually. A moment, please. A moment, please. Okay. So for this, so for example, so let's assume that so these are the standard function. You calculate your standard sum, average, then you have your count. Then if you are using the sequence formula, you use the sequence it calculates it for you from that. So let's assume I change this sequence to this row to 8. Let's see how it would. So if you change that row to 8, in the sequence formula, the sum actually changes. So we're having only um, 8 properties that we're actually calculating, as well as the average also would also change. So let's assume in this same formula, I need my count, my row count, to be this count function a moment. So this function will be here, J3. Okay, so that's what we are going to have. So the count function here is J3 here. So let's assume I change my count here. If I change my count here to 20, it calculates the 20 rows at once. But my standard function, I have to come and start editing. I have to come and start auto-filling all these rows to 20. But with this sequence function, I just have to change my count from where I am. So if I change this count again, for example, to just 7 and enter, you see the scores are actually changing to the number of count that I need. And also the sum and the average is also changing. So the difference between the good thing about the sequence formula, it enables you don't have to go back and actually be typing or trying to drag and drop to get a particular data set. So if you know that your count is actually in a particular step, so it's easy for you to use the sequence formula. It will enable you to do what, play around with that data without you having to going to autofill all the time. So if I want to increase this score now to, let's say, 15, for this formula to change, so I have to drag this. You notice that the formula is not changing because it has not captured the range. Because what did we say before in our formula? The range is between what? E7 and E16. And now I'm looking to how to calculate more than that range. So it's giving, it's telling that there's a rational number adjacent to it. So it's giving you that signal that this information now is wrong. You understand? But for sequence, if you're using the sequence formula to do your calculation, you just need to change your count. No matter what count you change it to, you notice that it will just calculate and auto-populate your scores for you. So let us go back to our other functions. Let's go back to our slide, please. So I've been able to use the standard formula to show how to do sum, do average, do count, as well as I use sequence to actually do all the same thing, these basic formulas that we have also, which enable us to do what? Have an effective data analyzed without us being cumbersome in either typing or trying to autofill that particular information. So the next information we're going to have is the Excel functions. There are several functions in Excel. Excel is actually very robust. So what we're going to be looking at is this function. We have the lookup function, the concatenate function, we have the text to column, and we have the if statement. So for the lookup function, what are you looking at? Lookup function and the if statements, I'm going to have the functions together, but the concatenate function and the text to column is like a reverse of each other. So let us go to our Excel data for us to be able to. Okay, so this function we're looking at it, I'm going to do the lookup function. All right, so I have this data already here. So I'll clean this out. So I can have another cell. A moment. Let me bring my grid lines back. I'm going to have another cell. I'm going to repeat this so that I had to have the data ready so that we don't have to. Okay. So this is, first of all, we're going to use the if function to actually work on the results that we have. To the results and the grade. So we have the name of students, we have the scores that they have, and this is the range of the scores, and this is the grade that we are looking at. So we're going to use an if statement to see if this result, if it is 40, what is it, a pass, is it a fail? You understand? Is it a pass, is it a fail? So this is what we're going to do here. So when you have data and you want to analyze data depending on what you are working on, and you have to use an if statement to do a comparison, like we said before in the logical data. So for here, we would be having is equals to have the if statement. If the score is what greater than score is greater than 50, it should be what? What's the value? The value should be what? If it is true, it should be what? Pass. That will be in a quotation mark. Later in Excel, it actually directs you on what you can do. So you need to be sure that you are looking at what Excel is presenting to you so that you don't make a mistake. Because you make a mistake, it will result in one of the errors that we actually talked about earlier. So for this person, Anita, I'm going to drag all my results down. So 43 is actually less than 50 on my if statement. So that's why what is failed. And Jones actually had a 55. So Jones passed because that condition is met. It was is greater than was 50. Silas' condition is not met because Silas is what? Silas actually did what? Have 30, which is what? Less than that particular condition. So that's why it represents fail. So this is how we use the if statement as what? A function to do comparison within different types of what data sets. It depends on what you're looking at. Now, apart from having all these results, so what are the grade that is attached to these results that we have? So that's why we have that function, a lookup. So we already have this function, grade and score, that accompanies the range of it. So it would help me know what my lookup function, what is it? So it's equals to having that function lookup. What's the value I'm looking up to? This is the value. And what is the vector that I'm looking at on? The result vector. I'm looking at this vector. That's the range. Then what's the array? What's supposed to represent? What's supposed to display? This is what it's supposed to. This is the array is supposed to display. The resulting vector. And we do what? We have this. So that grade. So you notice if I drag this, it will give me a different grade as I'm dragging. Depends on if this changes. But because I need this score the way it is constant 43, And what would I do? I'll put a dollar sign to show that this score is actually what I need to score the information the way it is. So we'll try it too and see what would happen. If I drag it now, so I have that. So let's assume I did not put the dollar sign. So let's see what Excel would populate. You can see. So what is Excel seeing? Excel is seeing this particular number first. Then it's seeing E3. What's E3? E3. E3 is 39. Sorry. This E1, 1, 2, 3. So this E3. So that's why he's giving you this what NA. We had discussed NA before. What is NA? When Excel does not understand what you're actually telling it to do. So it will give you this NA for that lookup. So that's why what did I do earlier? I needed Excel to recognize that I'm talking about each of those code the way they are on that range, on that rule. So assuming I change the numbers, it should also change the score, the grade for me. So I'll go back here. I'll add my dollar sign. I think how the errors we spoke about earlier actually happened, but Excel doesn't understand. With this, it gives the grade. So let's assume that I change my scores. I make this score 70. I make this score 10. I make this score 16. I make this 15. I make this 22. As you can see, as I'm changing the score, the lookup is changing. The if statement is also changing. So it's actually
Hello, hello.
analyzing. Hello, please.
Edo, yes, please. We have literally 1 minute to go
Okay.
to
Okay.
start the next session, please. Can we allow question time, please? For people that
Okay.
have question, can you please drop it in the comment section? We have just 1 more minute before we move to the next section, please. Thank you.
Okay. So we can have questions. Okay. The next one as also is co-catenate. Co-catenate is what I wanted to deal with. Okay, so let me rush over that. So we have first name and let's say surname, and we want to co-catenate means you want to add the two together and make it what a name, a compound name. So I don't mind if questions actually I could attend to questions also as
We need to wrap up now because we have
okay.
just 1 more minute left. Thank you so much for joining us on this session today. We really appreciate your coming. Please take your time to fill the feedback form for us to improve and get better on the session. So for the next session on this track, we have Essentials of Data Engineering. This is going to deal with Microsoft Azure Data Fundamentals. If you like to join us, please stay on to go to the YouTube channel. The link is there and you can join us. See you next week when we will have working with Excel charts and tables. We hope to see you same time next week, 3 to 4. Thank you, and thank you for coming. See you next week. Bye.